Hi, everyone, and welcome back to Organic Chemistry on YouTube. Today, we're going to be talking about the synthesis of alkenes from alkynes, specifically the peroxide-promoted reaction to add halides onto alkynes to produce vinyl halides. So this reaction is radical-based. That means we're going to have an initiation, a propagation, and a termination step. We need light to actually start the reaction, to initiate the reaction, and break that peroxide bond, which we'll talk about in the mechanism in the next section. And if this is a terminal alkyne, it's going to favor the anti-Markovnikov product. So let's go through an example. Okay, so in this reaction, we have a terminal alkyne. We're reacting that with peroxide, which is that ROOR prime group. We're using light, which I denote as H nu, and then HBr, or hydrogen bromide, which is used altogether to produce the two different products. Now, these two products, you'll notice, first of all, the bromine, less substituted end of the alkyne. That's the carbon that I've underlined in red. That one's attached to a hydrogen, while the other carbon, which I've underlined in green, is attached to a carbon. So the halide, in this case the bromine, will favor to add to, which is the unsubstituted terminus. Now from that, you can see that both of the products have bromine attached to that less substituted end of the alkyne, becoming an alkene. And we can see that the relationship between these two is that they're diastereomers. These are both cis and trans isomers of each other, and you can actually form both of them in approximately a 1-to-1 ratio. So this reaction is regioselective for adding the bromine to the less substituted end of the alkyne, but it's not stereoselective because it doesn't favor one or the other of these stereoisomers. So let's talk about the mechanism. In the initiation step, the oxygen-oxygen bond cleaves in a homolytic fashion, which makes an alkoxy radical, and in this case, because the R groups are different, another alkoxy radical. Okay, in the propagation step, one of those alkoxy radicals abstracts the hydrogen from the HBr. To make an alcohol and a bromine radical. There's a second propagation step where that bromine radical now can add to the alkyne. Right? And then if you add the bromine to the other end of the alkyne, I'm going to show that mechanism in red. Then we have these two possible intermediates. The molecule on top, or the blue intermediate, that radical is on a primary carbon. The top radical is attached to a primary radical. The bottom radical, that one shown in red, is a secondary radical. As we learned from earlier, secondary radicals are more stable than primary radicals, so the red pathway is going to be favored. So the termination step involves this radical abstracting a hydrogen from another molecule of HBr, the major product, where the bromine is added to the less substituted end. So questions you can ask in office hour: 1, why is light required? 2, are there any peroxide alternative? We know that peroxides are explosive, so maybe there's a better reaction technique. And 3, can this reaction be regioselective if it's not a terminal alkyne, if both ends of that alkyne are substituted? So with that, that's been organic chemistry in 5 minutes or less. Thanks for tuning in.